All right, so I found this Nix template recently and I started using it in my projects, and I've been a big fan of it, and I started trying to contribute to it and make it a little bit better for my use case. So I wanted to discuss like how it works and how I use it to do Haskell dev. So this thing uses a tool called Cookie Cutter, and I think it comes from the Python world, and it's pretty useful. But basically, the idea is you have this cookiecutter.json file, which describes like all of the different things that you can configure in your project, and then what it does is it goes through this cookiecutter.project name and fills in all of the places where we have these template strings. I don't remember what the template string is called offhand, but anyway, it's all here. So the basic thing that you need to make this work is Nix. So first thing you have to do is download Nix. So Nix download. We don't want NixOS, but I think that the download is here as well. So this is totally fine if you're doing a single user. If you need to do something more complicated than this, then there's more details here. But generally speaking, this is just how I get Nix as a tool. There's also NixOS, which is a different thing, but this is nixos.org/download. Okay, so once you have Nix, then you can just call this tool like this. I'm not going to use this exact command, and the reason for that is I have a PR that I'm working on that adds another feature that I want to show you so that I can discuss like my workflow. So we're going to run something very similar to that to build a new project. So you'll see the only difference is I'm running Nix shell-p. Actually, let me just pump that up a little bit. So Nix shell-p cookie cutter --run cookie cutter is exactly the same as what you see here. The difference is that this one is reaching out to GitHub and grabbing the Nix template off of like the main branch, and instead I'm using the local fork that I have here. So this is my fork that is set to the branch that I'm currently working on, which basically adds the ability to do HPAC with your project. So if we run this thing, in your case, you might see a ton of output if you just installed Nix and you've never used this project before, but that's how this will work. So we'll say like, here's a cat. Hi cat, could you get down please? So anyway, this is a cookie cutter example, and I usually don't fill this stuff out, so it's not a big deal. Watch out, kitty. There we go. So I am chiroptical. I am chiroptical. And here is where the tool adds a new feature. So the feature is that we're going to use HPAC instead of Cabal, which is the default. And I prefer using HPAC for this stuff because that's just what I prefer. We don't really need an executable section for the demo, so I'm just going to leave it off. This is another thing that we added recently to remove or to deal with. So anyway, we won't add that. So anyway, what this did is it created a directory somewhere called cookie example. I meant to write cookie cutter, but I didn't. Seriously, Layla, come on. Just sit like this. There you go. Yeah, that's great. Okay, so in this directory, we have a few things. And the first thing I want to talk about is this sources.json file. So this sources.json file is used by Niv to basically to pin down the Nix packages. So in our case, this uses Nix packages unstable, and that's really what you want to use. I know it sounds weird, but unstable is like the stable version for Nix, which is kind of confusing. But there's also like NixOS releases and stuff. Anyway, you want to use Nix packages unstable. If yours doesn't say Nix packages unstable, you can update it by first entering the Nix shell. So what the Nix shell does is it reads this file shell.nix, and it will get you into a place where you have all of your tools. So I'm going to write Nix shell like this one time, and you'll see what it looks like when I build this thing. So it says we're building what's called a derivation, which is coming from our default.nix. And you'll see that I've already done this, so it doesn't need to build anything. But you'll note one thing did happen is I've switched back to bash. And this doesn't quite work for me because I'm using fish. So if you're using fish, you can use this other tool called direnv, or Zish for that matter. So direnv. Yep. And what direnv does is basically allows you to add this file .nvarc, and in here you can literally just write use nix. And if you have direnv installed, you just write direnv allow. And what it'll do is it'll just enter you in the Nix shell automatically and set some environment variables for you. So now we're inside of a Nix shell. The reason I know that is, well, it's not like visible on my path in Nix shell. If you echo this environment variable, it will return impure, which tells you that you're inside of a Nix shell. Okay. And basically, anytime we make a change to our shell.nix, we'll we'll have this this thing here. Now, we'll re-enter the Nix shell using direnv, is what I'm trying to say. So the next thing is we have this tool niv, and what I want to do is update Nix packages, and I want to update specifically the Nix packages unstable branch. So you'll see like I had that saved, but that was actually the wrong command. So if we run this, what it will do is it will go fetch the newest version of Nix packages and stick them into that nix/sources.nix file. So in here, now we've updated our, well, maybe we haven't, but you want to make sure that this is up to date. It doesn't need to be like every week that you do this, but occasionally you're going to want to update it. So we can check that it worked by running something called direnv reload. And okay, so this is kind of interesting. We have this problem where the tool expected us to use GHC 10.4, but my guess is the newest one is slightly newer than that, so we got to update our compiler. So it's kind of nice that this actually errored, because I can show you a little bit more about Nix. So if we write Nix REPL, and let's just do the following. So I want to open up this default.nix file so we can look at it. And you'll see basically we have this compiler hard-coded here. So what we need to do is figure out what is the right compiler. And we can do that via just Nix REPL. So if we run this, we can basically just use the code that's already here. So we say, we leave these off. So we get our sources. Again, this tells us basically our Nix packages. And then we grab specifically the Nix packages out of that. So now we have this thing, packages, which contains like all of the stuff that we're interested in. So what we're specifically trying to find is what version of GHC is in here. So if we look in here, we have GHC 10.2, 10.7, but we don't have 10.4. So what we're going to do is update this to 10.7, if I could type. And then this way, we should be able to reload our Nix shell and things should work. So the Nix REPL is incredibly useful when you're trying to like search for stuff, and you can use the Nix files that are already in the directory kind of to guide you. And now you can see this is what normally would happen on a machine that didn't have this installed already. So it's going to just bring all this stuff in, and then all of it will be available in our shell. Okay, so we'll just let this go for a second, and I don't think that should take too long. All right, so this thing finished. It took a little bit longer than expected, but you only have to do this once, which is really nice. Once you have this pin set of packages and everything's set up, you're done. Like, that's it. You only have to deal with adding new stuff now, or you can remove stuff as well. So let's just look at a few things that happened. So everything above basically this line here is just it building, like getting packages that it needs to build this thing. Afterwards, it does it builds a Hugel database for you, so you can run Hugel from inside your project if you need to. It will include the documentation for all the packages that you've included, and then it does some this build propagation step to finish your derivation. I wouldn't worry too much about this. It's just like building your project. So, or sorry, it's getting the dependencies for your project. So now we have all of the dependencies that we need. So what does that mean? Like what did it actually bring into the shell? So if we go down here a little bit, so we saw this compiler, we saw this in the Nix REPL, and then some of this stuff I'm going to kind of ignore for now. When you get to the case where you need these overrides, it's nice that this thing is already here for you. And adding new ones is a little bit of a pain, but it's something that when you get further along with Haskell, it should be relatively easy. Generally speaking, you shouldn't have to worry too much about the overrides if you're doing what I'll say is like pretty boring everyday Haskell dev. It's when you start doing like exotic things or start having issues with dependencies that this will start to come up. But like, hopefully you're getting more familiar with Nix as you're using this template, and you don't have to like jump all the way into the ocean of Nix, because it's a pretty complicated thing. Generally speaking, when you interact with this thing, what you're going to include is this stuff down here. So your build inputs are all the tools that are used for your project. So in our case, we want to have a Haskell language server. And you'll see that comes from this my Haskell packages thing. And again, this is just like, you want the version of Haskell language server that matches your compiler. That's why you're using my Haskell packages here. So if you have a case where that's true, then you're going to use something like this. Everything else here doesn't depend directly on the compiler. It just uses GHC. So you can see we have Cabal install, GHCID, which is a useful tool, Ormalu, HLint, HPack, Niv, and Nix packages format. So this is just like if you wanted to format your Nix, you can do so. You don't really need to include this if you don't want. This is Niv. That's the tool I showed that we use to update our sources.json file. HPack is the tool that turns a package.yaml file into a Cabal file for the Cabal build tool. HLint just like tries to help us find inconsistencies in our code if you're not used to this. Ormalu is a tool for formatting, although I don't really like Ormalu. I tend to use this other one called Formalu, which sounds kind of funny, but that's what it is. GHCID is a useful tool. Occasionally I use it in conjunction with Haskell language server to do some things. And then we need Cabal, which unfortunately is called Cabal install, but you know, that is what it is. So if you want to turn off Hugel, you can turn off Hugel. And then if we look down here, there's some stuff here that we have these inherit phrases, which basically just include these things into our the output. Like this is the output of this default.nix. Okay, so we included Formalu. So now dearenv is doing the things it needs to do to get us Formalu. So now we should have which Formalu, and you'll see it comes from inside of this Nix store, which is basically where all of the stuff that we just installed went. And it has these hashes in here, so everything that's in here is unique. If you change your sources.json to, let's say, like an older commit or something, all of those paths might change. They may not. It depends if the package has been updated or not. Okay, cool. So we now have Formalu, we have Cabal, we have HPack. So how would you build your project? Well, you would do HPack and then cabal.build. And that will build the, this is the only line that comes from HPack. The rest will be Cabal. And you'll see that it'll just like build the thing. Okay, so there we go. We have something. So let's add a library just to do it. So I don't know. We want to import data.asyn, let's say. It can't find asyn you'll note that like Haskell language server is set up with my Vim, so it just works, and it's going to pick up the right version of Haskell language server, because if we do Haskell language server, it will pick the one from the Nix store, and so we don't really even need to worry about this. It's going to use the right version of GHC every time, and things are happy. Okay, so we include data asyn there, and you'll see if we just derenv real. Wait, no, we have to put this in package YAML first. So if we put this in package YAML, we want to include a dependency on, sorry, this is tests. We want to put that here, of asyn. And then we derenv reload. It should find asyn and include it. So you'll see that anytime you want to add a package, you have to do the Nix shell again, but notice that this is only like a few lines versus what there was before. So that's kind of nice. All right, so we include asyn. This is going to take a little bit longer, and then we should be able to hpack and build. Cool. So this is just like letting asyn fall through with everything, and then we should be able to hpack and cabal build, and it should be able to find asyn without building it. So that's the key, is because we did that derenv reload, you'll see that we did not build asyn. It just is included in our package, so we can just use it. Now, if we hlint, it will say it's oh, okay, apparently it won't. I would have guessed that it would have said that it was unused, but that's okay. I think Haskell language server will say that for us. All right, so that's kind of like how you include a package, and if you just include it in the package YAML, it just kind of works, which is really nice. But you do have to do that derenv reload step, or exit and enter the Nix shell. Because I use derenv, I don't really worry about that too much. If I'm unsure, I just derenv reload, or if I see Cabal building a package that I don't expect it to, I just derenv reload, and it kind of just works, which is nice. So you might like running this a bunch of times is going to get annoying, and so I don't know, I tend to just use a makefile to handle this complexity. So if we just like have the following makefile, this will just kind of work the way you want it to. So we'll cabal build, and then we'll hpack, which is hpack dot, and then we'll dot phony build and hpack. So if you just make a makefile like this, actually I should make sure that make is even in here. It is, so it's just included for you, which is nice. It must come as part of GHC, but it's here so you can use it. You just make build, and it will run hpack for you, and then just build, and everything's happy. The other thing that's nice about your makefile is you can start adding things like, you want to start Hoogle, but you don't remember how, because I never do. But I think it's just Hoogle server. Yeah, so you could just like make like little commands like Hoogle or hlint, or whatever you need to make, stick them in your makefile, and then you don't have to remember all of them. I tend to have makefiles that use the same kind of terminology all the time. Like if I wanted to, if this was like a backend server or something, maybe I would make serve, something like that, which would do cabal run. This is just a library, so we don't have cabal run, but you could also do make test. You're only saving one character by writing make, but if you had like multiple targets and stuff like this, then maybe this makes life a little bit easier. But I don't know. I'm totally fine with the old school makefile in this case. If you come up with any questions for me about like other things that you can do here, just let me know. Generally speaking, I find that this has helped me quite a bit. If there's some extra documentation here as well, and if you have like suggestions for me, just like let me know, and we can try and add those features or try to make it a little bit easier for you, something like that. There's one more thing in here that I'll mention that's kind of nice, is there is a Docker build in here. I don't exactly know how it works yet, but there's deploy to Docker image, so you can just use Docker, like you can just like serve an executable as a Docker image at the end of the day, which is kind of nice. I'm not a huge Docker person, but if if you wanted to like deploy an executable to, I guess, Heroku, it would be easy because you have a Docker image or, some cloud service. All right, cool. Thanks for checking this out. Have a good day.